Hey guys, today we're taking a look at intersection of two linked lists, which is an easy problem, but it's on the higher end of easy problems, and it goes through linked list traversal. So given the heads of two singly linked lists, you have head A and head B. You want to see return the node at which the two lists intersect. So in this case, you're going to return C1. Now let's take a look at an example with some real numbers so we can see what's going on. Right. So here we're given 4, 1, 8, 4, 5 as A and 5, 6, 1, 8, 4, 5 as B. It's kind of in the same order as the example, but we have actual numbers, and the node we want to return is 8. So 8 is the point at which they intersect. Now let's think about how we could do this. If we traverse through each of these lists in order, then we have at the first list node is 5, then second is first is 5, second is 6, third is 1, and then fourth is 8 for list B. But for list 1, first is 4, second is 1, and then third is 8. So these indices don't actually match. We want these indices to try and match, which means that we have to set their lengths equal to each other. Now, what do I mean by that? Imagine that this B didn't have this 5 at the beginning and it just started at 6. Then you can imagine that this would be much easier. At their third node is both going to be equal to each other. It's going to be 1, 2, 3, and at this third index, this third node, they're both going to be equal to each other. So that's simple, and it's simple because we've set their lengths equal to each other. What can we do to get their lengths equal to each other? Well, we could just traverse through each list separately. So for head A, we could set a temporary length variable, and then every time we traverse until we hit node, or until we hit that list A is null, we would increment a length variable, and then we would get the length for A is 5, and we would do the same thing with B, and then we would get the length of B is going to be 6. And once you're done with that, you would take the difference of these two, which is just 1, and then you would take the longer node and increment it by 1. So you would have head B equals head B.next, and you do that one time because the difference is 1. And then you would both start at the same place, and then you could traverse through each list one by one until you get to the same exact list node. But that's a little bit tricky, and we can actually do a little bit more optimized of a solution. So what we're going to do is we're going to try and ignore the fact that they have different lengths, or we're going to try to resolve that while not actually having these additional variables, because we don't want them. What we can do is, and this is a bit tricky, this is a creative trick, which is unexpected for an easy problem, is we can do this traversal 4, 1, 8, 4, 5, and instead, while it would normally, the next value would normally be a null node, instead we could set this next value to be equal to the start of B. Then if that's the case, what we'd have is we would have this list node, or this linked list, that looks like this: 4, 1, and then I'll set this green equal to their intersection, 8, 4, 5, and then we would have 5, 6, 1. And we could do the same exact thing starting with B. We would start at 5, 6, 1, 5, 6, 1, and then we would hit 8, 4, 5, 8, 4, 5, and then after that we would hit 4, 1. So what you'll notice then is that here the actual lengths of these two new lists are exactly the same. We've created two lists that are the same, and at this point then we are traversing in order for the next few. So we have 8, 4, 5, 8, 8 as both of these next values, and we can just immediately return this node. So what we did here is we traversed through all of A, and once we got through A, then we continued on to B. So we have all the individual unique elements of A, all the individual unique elements of B, and the elements of their merge. And the same is done backwards for B. So this is how it works, and we're going to try and write this in code, so try and follow along. Okay, one kind of edge case that wasn't mentioned earlier is what are we going to do if either of these heads are null, or if the linked lists are empty. In that case, then it could be no possible intersection, so we're just going to return null. And instead of doing that, if not head A or not head B, if either of them are null, then we will return null. And then what we're going to do is we're just going to do the iteration as I explained. So we'll let point A equals head B, or head A, and point B equals head B. And these are going to be the two pointers that first point A is going to start at A1 and it'll iterate through ending at B3, or just continue on to B, and then point B will start at B and then it'll continue on until it hits A. So our while loop is going to be while point A does not equal point B. Because remember, once we do this while loop, then we should have point A equals point B, which means that they should be on their second traversal, and we should have C1 as either one of them. So because point A is equal to point B at this time, then we can just say we can return either one of them, and it doesn't matter. So we'll return point A. This is going to be the specific list node C1, because point A is pointing to a specific list that is their intersection. All right, and then inside this while loop, we'll have a few if conditions. So if point A is equal to null, that means we've gone through this entire thing and we've set point A to null. So remember, this is pointing to null. If it points to null, we've gone through the entire list, then we can set point A equals to head B. We want to set point A equal to head B, right? We want this to continue on to point B. Otherwise, we're just going to traverse through the list, point A equals point A dot next. And we're going to do the same exact thing for point B. If point B equals null, once we hit a point where point B doesn't exist, then we're going to say point B equals head A, and do it the opposite way, and then otherwise, we're going to traverse point B dot next. And if we submit this, then it should work. Yep, and that's how it's done.